Assalamualaikum, everybody. All right, let's start our lecture number. Let me see, 25, and we're going to continue graphs. Probably this is going to be the last topic on the graphs, or we'll have an exam on Monday, and we'll start discrete probability on Monday as well after your exam.
अस्सलाम
Um,
वालेकुम सर
welcome, Star.
सर एक सवाल था could you just for a very brief एक overview दे सकते हैं of the terminologies that we use because assignment में भी काफ़ी confusion हो रही थी तो and मतलब नेट
Okay.
पे देखते हैं तो some words are defined differently in different sources तो समझ नहीं आता
Sir,
कोई पर्टिकुलर
tour
कंफ्यूजन
की
है तो
जो
बता दें.
tour की definition was very different on what we like looked up online और आपने जो बताई थी that was like different. तो वो
Okay,
कुछ
and circuit too
थोड़ी सी confusion थी.
circuit.
Circuit is
Okay,
the same.
circuit is a walk that starts and ends at the same node. That's the definition we are going to continue with.
And a tour.
so edges and vertices can be repeated in a circuit
Yep.
okay
And a tour.
And a tour is a walk that visits every edge at least once.
Okay, sir. But like what we looked up online said that it is a work that includes all the vertices at least once, and the edges must not repeat. So that is why we were a little confused.
No, that's not the definition of tour that we are using. So I understand there are usually some discrepancies, और ये in general है, तो but you need to remember my definitions, okay? The tour definition जो हम use कर रहे हैं, it's a walk which visits every edge at least once.
So just
Thank
to
you,
be
sir.
clear, we can visit an edge multiple times. For example, we can go from A to
Absolutely,
B,
yeah.
then A, then B, then A. That would
Yeah,
be a
yeah,
different.
yeah, yeah. और उसके लिए हमने फिर डिस्टिंक्शन बताई थी कि ऑयलेरियन टूर इज ए टूर जिसके अंदर यू विजिट एवरी एज एग्जैक्टली वंस.
Okay, got it.
Okay.
ठीक.
Anything else?
No, nothing. Thank you.
Okay, sure. ठीक है. So shoot me an email if you have any confusion. So I'm around here. Or there are possibilities कि different definitions हों. This is a new field in the sense कि every new book comes and तो उसके अंदर there are different definitions, but it's fine, right? As long as you define it और फिर उसके ऊपर आप काम करें, तो that's how it works in mathematics. Okay, you define it and then you go ahead with it. Your definition may not be the same as the definition of another guy. It's just a name of thing, right? टूअर हमने किसी चीज़ का नाम रखा है, किसी ऑब्जेक्ट का, किसी और ने टूअर किसी और ऑब्जेक्ट का नाम रखा है, तो it's perfectly fine. तो उस premise के ऊपर you move on, you state your theorems, you prove them, but you remain consistent. जो आपने कहा था, that remains valid. Okay, so it's fine. It's not a bad thing. All right.
सर
Yeah.
सर टूर में आप अलेरियन टूर में मतलब आपका वापस उसी जगह पे आना जरूरी तो नहीं है? Am I right?
वापस आना जरूरी है. वापस आना. So tour is a circuit.
Oh,
Okay. So tour is a circuit. You have to come back to the same point. Okay. मैं एग्जाम में अगर I'm giving you a question, तो मैं इस तरह की जो टर्मिनोलॉजी जिसमें कंफ्यूजन हो सकती है, I'll define it for you. Okay. Before the question.
Thank you, sir.
Sure. Any other question?
Sir, there is a subtopic in the book about the conditions for a Hamilton circuit और
Okay.
उसमें एक एग्जाम्पल 6 है पेज 700 पर अगर आप उसे बस एक दफा गो थ्रू कर देते तो कुछ क्लियर हो जाता.
Can you read it for me? Can you quickly read it?
इसमें दो ग्राफ्स दिए हुए हैं उसमें ये प्रूव करना है कि ये हैमिल्टन सर्किट नहीं है.
Okay.
तो एक ग्राफ का समझ आ गया था कि उसमें उन्होंने कहा था कि एक there exists a vertex जिसकी डिग्री 1 है तो that can not be a circuit. लेकिन दूसरे में कुछ इस तरह की कंडीशन दी हुई है कि it cannot contain a Hamilton circuit. वो मुझे समझ नहीं आया, वो ग्राफ देखकर समझ आएगा. कि वो क्या कहना चाह रहे
Okay, okay.
But
The
if
thing
you
is,
have
आज
time,
अभी मेरे पास थोड़ा सा टाइम कम है, okay? But send me
जी
an email, and anyone who is interested in learning कि उसमें क्या problem है, तो फिर we can schedule a meet. ठीक है?
okay, thank you so much, sir.
All right. Okay. So we have to cover a couple of things today. जिसमें सबसे important ये है कि I'm going to skip all of this and probably come back to it if we have time. The topic of coloring. वो हमने नहीं किया. It's a really important topic. और वो हम पहले कर लेते हैं. Okay. There are a couple of really nice things. It's a great topic और इस concept की applications भी हैं. Okay. Coloring is defined for, so coloring में what you do is you assign colors to the vertices or the edges. Okay. अगर vertices को color करें तो it's called vertex coloring, और edges को color करें तो it's called the edge coloring problem. Usually when people say graph coloring, they usually mean the vertex coloring. Okay, vertices को आप color करें. So coloring is just an assignment. आप उसको color करें. So for example, this is here is my pen.
एक्सक्यूज मी सर, स्क्रीन शेयर
क्या?
नहीं है, स्क्रीन
Oh,
शेयर नहीं
screen
है.
share नहीं है. Just sorry. I forgot to share the screen. Okay, so can you guys see it now?
यस सर.
Okay, once more. This is the start of lecture 25. We are going to do graph coloring, and time permitting, we'll probably do a couple of concepts of graph connectivity. Coloring I defined as a function from so it's a function from the vertex set to a set of colors. Okay, set of colors could be anything. Okay, it could be just numbers from 1 to k. Okay, or in colors का फिर नाम रख सकते हैं. You can call one red, you can call 2 as blue, 3 as yellow, and so on. Okay, so colors is just to make the thing intuitive. All this means is कि हम mark करें this vertices, for example, marking is 1 and so on. All right, so for example, here is a graph, and this guy has 3 vertices, so let me color it with 2 colors. Okay, तो मैं इसको 1 दे देता हूँ, इसको 1 दे देता हूँ, इसको 2 दे देता हूँ. Okay, so this is the coloring of this graph. अब there is something called proper coloring. Proper coloring का मतलब ये होता है कि every edge has 2 different colors. Okay, so as such हम edge के लिए तो color define नहीं कर रहे, but what it means is कि हर edge के 2 end points होंगे. These 2 end points must get different colors. Okay, if this happens, तो इस तरह के function को हम proper coloring कहते हैं. Okay, so coloring is any assignment of colors to the vertices is coloring. Proper coloring means that it's a coloring in which every edge, the two vertices on the ends of an edge always receive different colors. Okay, so for example, in here, every pair of vertices receive different colors. So this is actually a proper coloring. Okay, do we all understand what proper coloring is? Yes, no?
Yes, sir.
All right, so graph coloring problem क्या है? Graph coloring ये है कि आपको एक graph given है, and now you have to color the vertices, and you need to color them properly, which means that 2 adjacent vertices must get different colors, and the goal is you want to use minimum number of colors. Okay, तो इसको कहते हैं graph coloring problems. For example, let me give you an example of a graph. And let me use, so for example, I could use 4 colors for this guy, 1, 2, 3, 4, and then 3 here. Okay, so this is the proper coloring of this graph on 5 vertices. Okay, so C5, it's a cycle on 5 vertices, and I colored it properly. I used 4 colors. Okay, these 2 vertices, ये जो है, I don't know, this vertex and this vertex, these received the same color, but it's fine because they don't have an edge between them. उनके दरमियान edge नहीं है, so they can have the same color. But this is not the most optimal coloring, right? Because I can use 3 colors as well. Okay, so for example, if I color this node with 2, then the number of colors I'm using is 3. Okay, I'm using 1, 2, and 3, and that's it. And this is a proper coloring because every edge has 2 different colors on its incident vertices. Okay, so इनको आप color करना चाहते हैं तो you can definitely color them. So for example, I could use pink color for 2, so these guys would become pink. I could use yellow for 3, so this becomes yellow. I don't know, it's actually hard to make a yellow color here. Okay, all right, but you'll see that you can't color this graph with less than 3 vertices. Oh, sorry, 3 colors. You need at least 3 colors to color this graph. So the solution for proper coloring of this graph is 3 colors. Okay. This graph, this thing has many applications जो हम अभी देखेंगे अभी, लेकिन जो एक particular application है वो ये है जो practically use भी लोग करते हैं, वो GSM की band allocation है. Okay, so you have these states in the US. You assign bands, a different band for different states, but you want to use minimum number of bands. Okay, because बहुत सारे लोग यूज कर रहे थे, मिलिट्री भी यूज कर रही होती है एस्पियोनाज के लिए, और आपका प्राइवेट चैनल्स भी होते हैं और पब्लिक भी होते हैं. So there are limited number of bands available. You want to use minimum number of bands, and you want to make sure कि जहाँ पे state boundary है यहाँ पे कोई confusion ना हो. The band being used in here, for example, I don't know what state is it, should be different from the band of the neighboring state. Okay, so for example, if you're here in California, you may हमेशा नेवाडा शवाडा है, और ये आपके पास 3 states हैं, तो these 3 must use different bands. Okay, अगर bands ये different use नहीं करेंगे तो they would have a problem on the bordering cities जो भी होंगे. Okay, so every bordering, so but the thing is California वाला band आप यहाँ पे next state में use कर सकते हैं जो थोड़ा फासले के ऊपर है, बीच में एक और स्टेट आ जाती है. ओके, लेकिन इसके लिए नहीं यूज कर सकते ये जो भी है ऊपर. ओके, अब गोल ये है कि वो मिनिमम नंबर ऑफ बैंड्स जो आप यूज कर सकते हैं, सो दैट यू असाइन डिफरेंट bands to neighboring states. That's your goal. And this is the graph coloring problem. You can see it, right? You can imagine that each state is a vertex, and I will put an edge between 2 vertices if these 2 states are neighbors. Okay, and this gives me a graph, and all I want to do is I want to make sure that I can properly color this graph. Okay, do you see why this is a graph coloring problem?
Sure.
Yeah. Okay. So it's important. Here are 2 graphs जो मेरे ख्याल में 3 color किए गए हैं. So I think there are 4. Yeah. So in here they use 4 colors. Okay. They use red and green, yellow, and I don't know what is it, brown maybe. But this is not the most optimal coloring. This is probably the most optimal coloring because we use 3 colors here. और जब भी आपके पास एक triangle आ जाएगी तो आपको 3 color तो use करने ही करने हैं, right? If your graph contains a triangle, so you can't do with 2 colors. All right. So the minimum number of colors that you need to properly color a graph is called a chromatic number. इसको chi, it's a Greek letter chi, उससे denote करते हैं. It's sort of X, but it's sort of कर लिए इस तरह करके इसको लिखते हैं chromatic number chi. So just to understand how this works, what are the graphs with chromatic number 1? So these are the graphs जिसके अंदर कोई एज नहीं है, क्योंकि जब भी आपके पास एज होगा आपको 2 कलर तो यूज करने पड़ेंगे. Okay, so every graph which does not contain any edges is 1 colorable. Okay, so the only graph with chromatic number 1 is a graph without any edges. Similarly, now is the question, what sort of graphs are 2-colorable, and then there is a question, what sort of graphs are 3-colorable, and so on. Okay, and what happens in the case of path, cycle, and triangle.